Hi friends, welcome to this video on computation of last two digits. Now if you've watched our first video on computing the last digit, you would recall that in any computation, however large, for example, a number 4892 times 7847, the last digit of the last one digit, the units digit of my computation would depend only on 7 times 2, the last digit of 7 times 2. Yeah, 7 times 2 is 14, so the last digit of this computation is going to be 4. Okay, exactly on the same principle, if let's say we have a largish computation, 4892 times 7847, and let's say this time we were to find the last two digits of this computation. Okay, so the last two digits of any computation, again just like in the previous case, would depend on our computation of the last two digits of this number multiplied by the last two digits of this number. Okay, let me just show you how this works. So for example, in the regular methodology, if we were to compute 4892 multiplied by 7847, okay, now this computation, first I will multiply 7 by 4892, right? So 7 times 2 14, 4 I carry 1 over, 7 9 the 63 and 164. Now I'm not writing anything else here because they would not have an impact on the last two digits of my final computation. Okay, so I put a cross here and then I multiply 4 times 2. So in this row I have multiplied 4892 by 7. Okay, in this row now I'm going to multiply 4892 by 4 and I get 4 times 2 8, and anything to the left of this computation will not have an impact on my last two digits of the answer. Now I put two crosses here and this time I multiply 4892 by 8. Okay, and you would notice that this row and the last row, 4892 times 7, because I put in three crosses here, these two rows have absolutely no impact whatsoever on the last two digits of my final answer, right? So the last two digits of my final answer are 4 in the ones place, and 8 times 8 plus 4 12, so 2 of this computation. All right, so you notice that the only computation that matters to me in computing the last two digits of this product is 92 times 47. So if I get the last two digits of just this computation, it is enough to find the last two digits of this whole computation. So that's exactly what I meant when I said, if I were to find the last digit of this computation, I just use the last digit of this number times the last digit of this number, and boom, there's my answer. If I were to find the last two digits of this computation, I'll just pick the last two digits, multiply them, and whatever the last two digits of this answer, okay, is going to be the last two digits of my final answer. So clearly, any large computation, 4823728, so this is a very large computation. Let's say if I were to find the last two digits of this computation, then the last two digits of this computation are going to be the same as the last two digits of this computation. Okay, now this is exactly what we are going to use in our subsequent principles. Now you would notice that this not only holds true for multiplication, but it also holds true for addition and subtraction. Okay, so I'll just quickly finish up on the addition and subtraction bit also. So let's say you were doing 4892 plus 7847. My last two digits are going to be 7 and 2 9, 9 and 4 13, so 3 and 1 gets carried over, but I don't care what is there here because this is my answer. This is what I've been asked, right? And exactly, if I were to multiply, if I were to subtract 9 2 and okay, let's say I subtract 2847 from this number. So because this digit is smaller than this digit, I need to carry 1 over from here, so this becomes a 12 minus 7, I get a 5. Okay, but because this one is one short now, so this is 8 minus 4, 4. That's it. That's my answer. That's the last two digits of my subtraction. Okay. Now to find out computations as large as these, okay, I'm going to segregate my problem into three basic types. Okay, so finding out last two digits, essentially if my last digit of the base is 5, okay, that's one thing I'll study. The second thing I will study is if the number that I'm going to be figuring out this answer for is an odd number, okay, and the third thing I'm going to do is powers of 2. Now right now this may seem pretty odd, yeah, multiples of 5, an odd number, powers of 2, but you would notice, as you know, as this session goes on, you would notice that all numbers I can actually I can you know break them up, or I can break up my problem into any one of these sub problems and solve for my answer ultimately. Okay, don't worry if you don't see the point in me breaking up this problem into these three sub problems, but subsequently by the end of this session you will see the point. Okay, so let me take up the first case, last digit being 5. Okay, now last digit 5, I've written down an example here. So last digit 5, okay, so the number I've taken is 35 and the power that I'm trying to compute is 25. Now in here, this number would invariably be a certain number times 5, okay, and I can, if I were to open this bracket up, this certain number, right, times is multiplying with itself 25 times, and I have 5 to the power 25 here. So 5 after the power 2, right, so once it becomes 25 in the last digit, all its powers are going to be either, they're going to end up either with 25 or a 75. Okay, and the way to look at it is as follows. So let's say if I have 35 squared, okay, so 35 squared is going to look like this. 35 times 35, I have a 5 5 the 25, I have a 5 3 the 15, and then I have a 5 3 the 15, and I'm not going to compute anything else here, so I have 25. So you notice that the 35 squared has last two digits 25, yeah, but if I multiply whatever this answer, right, so let's say my answer 35 times 35 is dash 25, so when I multiply this by another 35 to compute the last two digits of 35 cube, I get 5 times 5 25, carry 2, 5 to the 10 and 12 2, I don't care what here is, then 9 5 3 the 15, yeah, and I can ignore the rest and I get 75. Okay, so 35 square last two digits 25, but 35 cube last two digits 75. So any number, any base number with the last digit 5, okay, I'm invariably going to end up with the last two digits 25 or 75. Okay, but then how do I figure whether it's going to be 25 or 75? Now the thumb rule for this is fairly simple. Okay, the thumb rule is that whatever the number, right, to the left of 5, so let's say I have 3 in tens place, okay, and I'm going to compute a certain power. So I just need to write 5 as my last digit. Now between 7 and 2, okay, between 7 and 2, what should come here? That's the question I must ask myself. Now if this number adds up to an even number, so I get, so this 3 is going to add to itself 25 times to give me a 75. Okay, if this adds up to an odd number, 25 times 3, if this is an odd number, I'll give it a 7. Okay, however, if I were doing this, okay, so the last digit is 5, however 3 gets added 28 times, I get an even number, so 3 times 28 is even. Now if this is even, then this digit has to be 2, as you notice here. So when I do 35 squared, I have 3 adding up twice, 6, that's an even number, and I get a 2 here. But when it was 35 cube, I had 3 adding up 3 times and I had an odd number, right, 9, so I put a 7 here. Okay, so I hope this bit is clear. So let's say I were multiplying, I'll take another completely different example. Let's say I were multiplying 45 by 75. Okay, so the last digit has to be a 5. However, if let's say 7 plus 4, it becomes an 11, becomes an odd number, so I'll just straight away, without even thinking too much, I'll put a 7 here. Okay, so 75 is going to be the last 2 digits of this product. Okay, so I hope the last digit 5 is fairly clear. Now moving on to the next idea, where we must compute the last 2 digits of odd numbers. Actually, other odd numbers, let me call it other odd numbers, or other odd numbers or digits in the end. Okay, now the thumb rule here, let me just start with this number 21. Okay, and let's multiply 21 by 21. What do we get? We get 21 times 21, and just pay attention to how this is multiplied. So this row is 21 times 1. Okay, so I just write 21, put a cross here. Now this row is going to be 21 multiplied by 2, this 2. Okay, so I get a 2 1 the 2 and 2 to the 4. Okay, so because I don't care what comes here, this digit is 1 and this digit is 2 plus 2, 4. Okay, so the last 2 digits 4 1. Okay, and keep paying attention how this moves. Now if let's say I were to find 21 cube, it is going to be 21 squared times 21. Okay, so the last 2 digits of 21 squared are 4 1. Okay, and let's multiply this by 21. Okay, and this is how it will look. So something 4 1 multiplied by 21. Okay, so last 2 digits, so this is something 4 1 times 1, and I get something 4 1 here. Okay, put a cross here, and this becomes something 4 1 times 2. Okay, and therefore I get 2 1 the 2, and then I ignore everything else. So what do I get? I get a 6 1. Okay, so this is equivalent to something 6 1, and you keep doing it and you will notice that 21 to the power 4 would end up in 8 1. 21 to the power 5 would likewise end up with a 0 1, and so on. Okay, so what is happening here, if you pay attention, it's essentially a 2, this digit, a tens digit, getting added to itself every time. Okay, so if I were to generalize my situation here, what I would get is, so let's say if there were a number, let's say 31. Okay, now 31 to the power 2, I should get my last 2 digits as, so 1 stays. Okay, the second last digit, the tens digit, is going to be 3 plus 3, 6. Okay, 31 cube, my last 2 digits should be 1 here, 3 times 3, 9, and so on. Okay, so likewise, if I were to extend this logic to an even bigger number ending in something 1, so let's say I have a number 4 8 7 2 4 1. Okay, and let's say I were to find its last 2 digits of this power 3, L2D of this power 3, it will be equivalent to the last 2 digits of, let me ignore everything here, 41 to the power 3, and the last 2 digits of 41 to the power 3 are simply, I'll just use a 1 here, and 4 times 3, 12, last digit of 12, 2. Okay, so that's how this is done. Now I'll come to why I have explained the last digit 1, okay, and the powers of this in a little while, but don't worry. Okay, now the next thing I'll teach you. So this is the first thing that we did odd multiples of 5, that's done. Second thing we've done is we've done odd numbers or digits, or odd digits rather, in the end For that, I've just touched upon the 1 here, last digit 1, okay, and you'll very soon understand why I have not done it for a 7 or a 9 or a 3, okay. The third part of the puzzle that we must put together, okay, is powers of 2. Now powers of 2 have a very interesting way of going about, okay, the last 2 digits of power of 2. I'll just straight away go to 2 to the power 10. What is 2 to the power 10? You'll compute it and you'll find out that the 10th power of 2 is 1024, okay. Now what is 20th power of 2? 20th power of 2 is the squared of this number, okay, and let's find out the last 2 digits of that number. 1024 times 1024, I get 6, 4 to the 8 and 1 9, 4 to the 8, okay, and I get a 7 6. I've just ignored everything to the left, okay. So the last 2 digits here, last 2 digits of this computation are 24, and last 2 digits of this computation is 76. And let's move on to 2 to the power 30, okay. Now this is nothing but 2 to the power 20 multiplied by 2 to the power 10. So I'll just multiply something 76, which is the last 2 digits of 2 to the power 20, okay, and I multiply it by the last 2 digits of 2 to the power 10, which is something 24, okay. So what do I get? 6 for the 24 and 2, 7 for the 28 and 30, okay, ignore the rest. 6 to the 12, okay, and I ignore the rest. So wow, what do I get? Again I get a 24, okay. And in the similar the similar idea, 2 to the power 40, I should get 76, and therefore it is fairly clear to see that if I have an odd power of 2 to the power 10, I will get 24 in the end. If I get an even power of 2 to the power 10, I'll get a 76 in the end, right? Now I have done 3 things, okay. I've done multiples of 5 on this previous sheet, okay. So in this part I've done multiples of 5 and how do the last 2 digits of their power run. I have done odd numbers, okay. In odd numbers I've just done the last digit 1 and how do the last 2 digits of a power of a number ending in 1 works, okay. And the third thing I've done is the powers of 2. Now it is time to piece all of them together and show them to you with the help of an example, okay. So let me start with an odd number, and let's say I got to find out the last 2 digits of 73, okay, 73 to the power, let's say 27, okay. Now you would recall that when we did last digits, 3 has a cyclicity of 4, okay. So 3 having a cyclicity of 4 means that ultimately somewhere down the line 73, some power of 73 would have the last digit 1, right? Now does it start to make sense? The second thing that the second part that we did here, we've figured out how to manage when I have the last digit 1, right? So what I'm going to do is I'm going to move the 73 and its power somehow to last digit 1, and I'm going to use this principle because this is easy to understand, easy to apply, okay. So 3 the 9, 3 the 27, 3 the 81. So clearly the fourth power of 73 will give me a 1 in the end, okay. But 27 is not a multiple of 4. 27 is 24 plus 3, okay. So I'm just going to break this up into 73 to the power 4. Now what I get here is 4 6 the 24 multiplied by 73 cube, okay. So this one now 73 squared, last 2 digits are 3 times 3 9, 7 3 the 21, 7 3 the 21, 29. Okay, so 73 squared, last two digits 29. So 73 squared multiplied by 73 squared, I will get the last two digits of 73 to the power 4. Okay, so what I'll get here is 9 times 9 81, 8, 9 to the 18 and 8 26. So I'll just write a 6 here, 9 to the 18, and I get 1 and 4. Okay, so this is 41, something 41 to the power 6 multiplied by 73 cube. Okay, now I got to find the last two digits of 73 cube. Now I already know that 73 squared, last two digits are 29, so I'll just multiply. I'll just let me just use this part here. So 73 squared, last two digits 29. Let me multiply this by another 73, and I get 9 3 the 27, 2 3 to the 6 7 8, 9 7 the 63. Okay, so when I add these up, I ignore the rest. Okay, so when I add these up, I should get something 7 8 and 3 11. Okay, so I get 1 7 as the last two digits of 73 cube. Okay, so this multiplied by something 1 7. Okay, so I got to ignore whatever is to the left of these two digits. All right, now this I know, 41 to the power 6, I know. How does it work? I just need to write 1 here. So I'm solving the first bracket here. So I just need to write a 1 here, and the tens digit is going to be 6 4 the 24. I write a 4 here and something here. So 41 to the power 6 is still going to have 41 in the end, multiplied by something 17. Okay, so now my computation is fairly simple. All I got to do is multiply 17 with 41. So I get a 17 here, and I get 7 4 the 28, so I get a 9 7. So my answer is 9 7. So does it start to make sense why we had studied last digit 1, why we had studied how to find out the last two digits when the last one digit of the base is 1, right? So because anything having the last digit 3 or 7 or 9 will ultimately end up with last digit 1. Some power of it will invariably end up with a 1. Okay, now let's combine this with let's say any power of 2, and let's say we got to find out 126, and the power is let's say 47. Okay, so here I got to separate 2's out first. Okay, so let me just get a 2 here. So this is 2 times 63 to the power 47. Okay, so I'll just separate out 2 to the power 47. So I'm trying to find out the last two digits of 2 to the power 47 multiplied by 63 to the power 47. Now 2 to the power 47, I know how the powers of 2 to the power 10 run. Okay, so this is 2 to the power 10 whole to the power 4. So I've completed 40 here multiplied by 2 to the power 7. Okay, so this completes 2 to the power 47. And for 63, I'll again use 3, 3 the 9, 3 the 27, 3 the 81. So the fourth power of 3 is a 1, which I know how to deal with for in terms of last two digits. So I'll just do 63 to the power 4. Okay, but 47 has the closest multiple of 47 is 44. Closest multiple of 4 inside of 47 is 44. So this is 4 times 11, 44 multiplied by 63 cube. Okay, now 2 to the power 10, I know that any even power of 2 to the power 10 will give me 7 6 in the end. So straight away I write a 7 6 here. Okay, so this is something 7 6. Now 2 to the power 7 I can compute. So the powers of 2 are 2 squared is 4, cube is 8, 16, 32, 64, 128. Okay, so 2 to the power 7 is 128. So I'll just write 2 8 here because I don't care for 1. Okay, then 63 to the power 4. Let's compute last two digits of 63 to the power 4. So I'll first compute 63 squared, 63 times 63. So 3 3 the 9, 6 3 the 18, 6 3 the 18. So this is 9 and 8 and 8, 16, 6. So that's all I care about. So this is 63 squared, but I must multiply it with another 63 squared, which is 69, to get 63 to the power 4. Okay, so this is 9 9 the 81 and 8, 9 6 the 54, and it becomes 62, 9 6 the 54. Okay, so I get a 61. So 63 to the power 4, last two digits 61. So this becomes something 61 to the power 11 multiplied by 63 cube. Okay, so 63 cube is what? 63 squared, last two digits 69, times 63. So I get 9 3 the 27, 6 3 the 18, 19 20, 9 6 the 54. So last two digits 47. Okay, so this is the last two digits of 63 cube, right? So this is what my problem has simplified to. So this is 7 6, this is 2 8, this is 61 to the power 11 is, I'll just straight away write 1 from here, and 6 11 the 66, so 6 here, times 47, right? So I just got to compute the last two digits of this product. So let me just use up this space. 7 6 2 8, 8 6 the 48, 4 7 8 the 56, 60, 6 to the 12, so 28. So this is again 28, 61 times 47, 47, 7 6 the 42, and I get a 67 here. And last computation, 8 7 the 56, 5 8 6 the 48, 53, 7 to the 14. That's my answer. Okay, so so what we have done is we have actually split our problem of finding two digits into three parts, and depending on what the base is, for example the base here was even, so we separate out the powers of 2 and use this. Okay, so whatever odd number I'm left with, either it's going to be a multiple of 5 or it's going to be last digit 3 1 3 7 or 9. Okay, so 1 I know how to do, and 379 will ultimately have some power which ends in 1, and I can use concept number 2 that I've just discussed. Okay, guys, I understand that this is a fairly complicated thing to learn. However, don't give up, don't lose hope. I would recommend watching this video a few times. You can rewind, play with it as much as you want, okay, and ultimately try and get your answer.